Hello, everyone. Thanks for joining us today. Our next session will be led by Anish Agarwal. He is a Director, Data and Analytics at Royal Bank of Scotland. Please join me in welcoming him to our virtual stage.
Thank you, Patricia, for that welcome. Good morning, good afternoon, good evening to all the attendees. A very warm welcome and thank you for joining this session. I am Anish. I work with the Royal Bank of Scotland in the capacity of Director for Data and Analytics. Today, I will be spending another 20-25 minutes taking you through a journey which is about talent, technologies, and foresight, and in terms of what next. The patterns of the session is all about AI and machine learning. You've heard a lot about these terms, and I thought it will be a good opportunity for us to go back to the journey and also try to understand what are the trends and what's really keeping all the data scientists in the data science space busy, and what is it that we should be looking forward to. So I've split this session into 4 parts. We'll start with the talent first, which in my view is the secret ingredient to everyone's success. If you look at the overall data science in a Venn diagram, there are 3 key quadrants that emerge. First, of course, is knowledge of computer science and IT. The second is the maths and statistics. And the third is the domains and then the business knowledge. Now, the interesting part here is if you are an expert in computer science and you know the business well, that's where you would probably end up into the software development side of the story. If you know the computer science or you are a technology geek and you know maths and stats, that's where you end up becoming a machine learning expert. However, if you are good in maths and stats and you have a good business knowledge as well, that's where you get into the traditional research side of the story as well. The sum total of all these 3, that's a good knowledge of computer, maths and stats, and the domain knowledge actually makes a good data scientist. And that's what data science is all about. So what really are the skills required for one to excel in data science and build a career in AI and machine learning? I would say one, of course, is a solid maths and algorithms knowledge. An ideal candidate for the AI domain must have an expertise in a broad set of algorithms and applied maths. You should be well versed with problem solving and analytical skills, which could help you in performing the given task in an efficient manner. Second is you should be well versed with probability and statistics. Knowledge of probability and stats is always important as it helps you to understand different AI models as, for example, the hidden Markov model, the naive Bayes, the Gaussian mixture models, etc. These theories do help you in learning about complex algorithms as well. And I must say the statistics is also a prerequisite to be an efficient AI professional as well. You should be well versed with navigating the basics of stats models and methods using which are helpful in model evaluation as well. Expertise in programming languages is also emerging as an important ingredient day by day. You must know the ingredients of languages like Python, SQL, R, and as Python also makes it easier for you to create complex algorithms as well. This was a recent survey that was done by one of the leading magazines in India, which actually researched all the data scientists, professionals in the AI and machine learning space. And if you look at the charts on the slide, in terms of languages used for statistical modeling, clearly Python leads the edge, where 65% individuals are, or organizations across India are currently using Python. If you look at the data science models, logistic regression tops the chart with close to 24% individuals using this specific model, followed by random forests, XGBoost, and artificial neural networks. And if you look at the Python journal purpose libraries, Pandas is something which is most popular, most famous, and in my experience, it's one of the most agile libraries as well, followed by NumPy and scikit-learn as well. Fourth, on the non-technical side, is the critical thinking part. We should be taking nothing at the face value. We should be naturally curious, believe in trial and error, and test and experiment before making a concrete decision. That's really important. Curiosity is another important aspect. Gone are the days when there was a saying that said curiosity kills the cat. Always wanting to know more. Artificial intelligence, individuals or professionals would want to know how things work. You just don't look, you observe, you hear, and most importantly, you listen. Perseverance and patience is very important. I'm sure you would agree that artificial intelligence and machine learning technologies, are all about try, test, and trial. This is why you should have a persistent attitude, which is beneficial to make you patient enough to cope with several months and countless iterations to achieve an accurate result. I've also complemented some tips in terms of how to excel in AI and machine learning. We have an opportunity to work on real life case studies and projects, while majority of us are already working on such case studies and projects because we've got a full-time employment. If that's not the case, there are a number of web sources which are currently available, which runs a lot of competitions, also offer you free data sets as well, and you should really be practicing them. There are specific areas within this entire AI ecosystem which we would need a detailed understanding of, which will actually help you to focus. As an example, there's a difference between data analysts and data scientists, data visualization expert and a data engineer. And then comes other aspects around deep learning, AI, and natural language processing as well. So it's really, really important that one should have a clear understanding of what these roles are all about, because the difference is as grave as what a difference between a doctor and an engineer. One should have an understanding and try to understand what is the focus area and start building the career in that specific stream. It's important to keep track of latest developments in this space. One of the best ways I do this is I've set up Google alerts. It really, really helps. If you do this, every day in the morning you get an alert from Google in your inbox, which actually brings you the latest in the world, what's really happening around this. And it actually helps you to pick conversations with your peers, with professionals, and even with thought leaders as well. Identifying a mentor is really, really important. Personally, it has helped me a lot. It helps to gain an external and outside view beyond the ecosystem of an organization where we are working. The reason it's important is there are opportunities, or there are instances where we may need some sort of course correction. And this is where a mentor can actually guide, because the mentor actually brings an outside view to what we're doing, and it really helps to manage things in a better perspective. Let's talk about technology and how big data and analytics is empowering AI and machine learning. So we are all aware of this, the emerging data economy, the fourth industrial revolution, and the big data. Data was defined by the Economist magazine as the world's most valuable resource. It's less of bits and bytes. It's more about a commodity right now, which is very, very important. And today it is understood to be as important raw material as others, or as important ingredient or for an organization to operate. So if you sum total the technology and the data, it's all about driving the innovative change in the market, in the industry, and that's why it's also understood as the fourth industrial revolution. This is a famous quote from Sir Tim Berners-Lee, who's an inventor of World Wide Web. And I had an opportunity to interact with him a few years ago. This is what I could learn from him. And he said that data is a precious thing and will last longer than systems themselves. That means data is agnostic of the tenure. If we have access to the historical data, that actually means that it's equipping us to run a lot of analysis, meaningful hypothesis, which actually can not just help us to review what's really happened in the past, but also forecast what's going to hit us very soon. You've all heard this, the big data. It's all about large amounts of data which is collected passively from digital interactions with great variety and high rate of velocity. What's really important here is to understand the word passive and digital. Big data is all about a huge data set which is collected passively. We cannot create a data set which is forecast, which is based on what's going to happen in future. And the digital side of the story as well. It's all about the digital data aggregation using the various platforms which are digital, whether it's IoT or computers or mobile phones or smartphones as well. And of course, the variety and velocity. We'll have a look at this in the following slides. Whenever we talk about big data, there are 5 V's which we should always be focusing on: the velocity, volume, variety, veracity, and value. Think of an example from a value perspective of Uber and Amazon. None of the organizations, none of the companies hold. So as an example, Amazon doesn't have a manufacturing setup. Likewise, Uber doesn't own a single cab. However, both the organizations today are pioneers in the sectors they operate in, for only one reason: because they are able to monetize the data that they have access of. Both the organizations provide a platform which acts as an intermediary between a buyer and a seller. So in the case of Amazon, it's a platform where I, as a buyer, would need certain product which is positioned by the seller on the platform. versus Uber, where I, as a passenger, have a data point in terms of the place where I want to travel and the location of the driver as well. Both these platforms are only what they're doing is monetizing the available data set, and look at it. They actually have emerged as part of the most valuable companies in the ecosystem they operate in. So how big is big data? Thanks for Domo. This is a recent slide they published. 2020, every minute of the day. Look at this. Netflix users stream 404 more than 404k hours of video and that's every minute of the day. YouTube users upload 500 hours of video every minute of the day. Facebook users share 150,000 messages every minute. Look at the volume and the variety of data. If you talk about the Netflix and the YouTubes, it's all about the video side. Twitter is all about the qualitative data, which is the text side of the story. WhatsApp messages, again, is the text. Facebook photo uploads is photograph. LinkedIn users apply for 69,444 jobs. Look at the level of transaction that's happening. And Amazon ships close to 6,600 packages every minute. How that's the velocity and the variety of data. And as it's also said, data never sleeps. What's also important for us is to understand the overall cloud ecosystem which is now emerged. These are the top 4 players in the cloud, and what's really interesting is to understand all these players have very passively got into the artificial intelligence side of the story as well. Amazon Web Services are equipped with popular deep learning frameworks to support over 1 million customers in more than 190 countries. Microsoft Azure, cognitive search also allows companies to discover patterns and relationships in their content using the cloud search service with built-in AI capabilities. Google Cloud's AI Hub provides companies with enterprise-grade sharing capabilities, which includes end-to-end AI pipelines as well. And IBM Cloud, why should it be laggard in the league? It still is. It's also one of the pioneers in the cloud. The Watson Cloud allows companies to infuse AI into their applications so that they can make more accurate predictions, automate the company decisions, and process and obtain optimized solutions as well. One of the best use case of IBM Watson is the AI-enabled chatbots, where you just type in a query and you get an instant response based on the model in which the chatbot has been trained on. So what's really driving all this? We understand that there's a lot happening around AI, machine learning. We've got access to big data. Nothing of that sort was available 5 years ago. So what are the key drivers? First, of course, is the capital. If you look at the overall capital that's been pumped in 2019, that's last year, 18.5 billion USD was raised by AI startups, and that's big money. And if you look at in the overall deals, it was reported that 136.5 billion, that's close to 140 billion dollar worth of money that was raised across 10,777 deals in 2019 across the globe. We now have a better understanding of algorithms like deep learning and hierarchical pattern recognition, which acts as a major force driving the adoption of artificial intelligence. Softwares like RStudio, Sentinel, and companies would have never thought that getting into AI suddenly is possible for them. But today, every organization wants to have an AI function which talks about, how can you automate? How can you actually move to the next phase of the evolution of the product or service that you're currently providing? The data, we already spoke about the volume, the veracity, and of course, the speed at which data is emanating. In the last 2 years alone, an astonishing 90% of the world's data has been created, and which is equivalent to close to 2.5 quintillion bytes that are produced by humans every day. And of course, if you look at the applications, we experience AI through applications we use. When first released, Siri had plenty of issues, but today, if you interact with Siri, Microsoft Cortana, or even Google, Assistant as well, they're much more accurate to an extent that the level to which they have been trained. It's all about how well they have been modeled to use the data. Let's look at the foresight, and the future is amazing. And this is where there comes a challenge, which is the game of algorithm bias as well. Big data is algorithmic, therefore it cannot be biased. However, we still see a lot of biases, and we see a lot of examples. We see a lot of articles in the newspaper where there's some organization which designs a model and which led to bias as well. And all traditions level of social discrimination, many new ones exhibit themselves in the big data ecosystem. Because of its tremendous power, massive data must be used responsibly. So if you look at the four aspects, the fairness, diversity, transparency, and neutrality is something that companies would need to manage and take care of. How does bias enter the system? I think that there are three key reasons why a bias enters. One, of course, is assumptions. As human beings, we can't always understand everyone else's experience or predict how a given system will impact others. And that's where we end up assuming things. The training data could be incorrect. So let's say, the popular example of training data, if you're training a model on identifying a cat or a dog, if the model is exposed only to white dogs or a certain color of dogs, that's when, if you expose the model to a cat or to a dog of some other color, it may fail as well. So your training data has to be comprehensive and should have a well-rounded approach. And the third, of course, is a model. The factors used in the model, such as race, gender, age, can result in recommendations or predictions that are based, or biased against certain groups. The most popular case studies are the Amazon recruitment, bias in the model, which actually didn't really work well, or probably the model on basis which the certain law systems in the US were designed, which actually led to a lot of bias around judgment, and it actually had to undergo a refresh. So how should we prevent the algorithmic bias? I would say, one, we can use a representative data set, which is all about feeding the algorithm data, which is the most important aspect. Placing all different types of groups of data into a data set can be challenging, not at least because we will need to segment the data, but we need to be sure we have properly grouped and managed the data. If we have insufficient data about one group, we can weigh groups against each other to increase its importance during training. But we must be aware that this can lead to new unexpected biases as well. So clearly, if there are any outliers, we need to take care of them. The second is, we need to choose the right model. Every AI algorithm is unique, and there is no single model that can be used to avoid bias. It is important to utilize the best possible model for the problem at hand. For example, supervised learning may prove more accurate, but can be subject to human bias and cognitive limitations as well. The third is monitor and review. Testing is paramount to the success of any application. We need to ensure that there's rigorous testing in place. Having successful results in controlled test environments might give a false belief that algorithm is foolproof. However, if algorithm fails to factor for an unforeseen variable in the real world, it could be the designers, the creators, which may need to be blamed, especially if the consequences are negative for the end use. So how will consumers interact and make decisions based on AI? I think first is empowering the self-service. Today, we see a lot of self-service options which are available to us. And as recent as COVID actually has led to a new sort of innovation where you can walk into an ATM and it's a non-touch process. You don't even have to touch the ATM machine, and you can withdraw money. That's also sort of a self-service. Improving personalization. There are a number of avenues basis which you can get personalized service. Amazon being one of them. You get personalized recommendations. Netflix, you get personalized recommendations. And to an extent, there are a few banks which are now actually looking at the data of the customer's transaction or interaction with the bank and trying to modulate the needs of the customer and offering personalized products and services to the customers as well. The availability for 24/7. Gone are days when we had reliance on a call center agent or an assistant where it was just a 9 to 5 or 9 to 6 window. Technology is available 24/7. Data never sleeps. That actually means that be it a chatbot or be it any other service that you're using, it's available to you virtually at any given point in time. Allowing for automated life assistant. If you look at the source of Amazon's Echo, these are all life assistants. You just give a voice command and they come to the rescue, and they complete a number of tasks as well. And especially in the current context of COVID, you don't need to touch. You just if you events these are integrated with IoT, there's a lot that can be achieved as well. And providing a happy customer service agents as well. The chatbots, for sure, there is no issue of a customer service agent being upset, or there is an element of rudeness as well. I think it's all automated. While there are still a lot of research and rebalances going on in terms of looking at the emotive side of how well can a customer need be responded, I think we still have way to go around it, but still majority of questions and queries can be resolved by these automated agents. So what's really happening? Let's look at the trends. we've already looked at it. Python has already moved to #1 position, being one of the world's most acceptable programming languages and platform. And the beauty about Python is it is not just about analysis or analytics, it's also about the agility it shows in terms of integration with the front-end APIs as well. So what that means is you're not just able to run the analysis, do analytics, do a data science in the historic data set, but given it's integrated with the live API, you actually have an ability to transform the results and showcase the outcomes to the customer, and also in turn review what's really been fed or data that's been accumulated based on the live interaction, and real-time analysis can be run as well. AutoML, talk of the town, a lot of questions around will AutoML kill the jobs? What's the future of AutoML? Well, let's try and understand AutoML is all about automating a certain portion of the machine learning algorithm, which is trained by a human being. You will still need humans, you will still need data scientists, you will still need data engineers to modulate the data, to define the logic. So AutoML definitely is a hot topic. It will actually reduce the manual effort, but the opportunity is how well organizations actually use the residual manual effort that's been saved in deploying those resources to think logically and design and articulate new sort of models. NLP and conversational analytics. We're now talking about a lot of prospects around NLP. There was a recent release by Google where the Google Assistant was trained to make a phone call to book, to complete certain processes. I think this is the beauty around NLP. Better we have the ability to train the models in terms of getting the understanding of what humans are interacting on. It actually would mean that there's more conversational analytics. That means whatever we are talking, it's the ability to translate speech into text and then analyze that text and derive meaningful analysis, sentiment analysis, and whatnot. Supersized data science in the cloud. Cloud as a technology is really up in the market. We've already seen the key players in the market as well. I think it's next big thing. The cloud as a setup, as an ecosystem, offers a lot of resilience, offers a lot of data security, and offers a lot of agility to the organizations in managing the data, which is all about 24/7 availability and availability from any location across the globe. Diminishing model biases and discrimination, there is a greater sense in the organizations to understand and evaluate biases, which actually would mean there would be less in instances or less aspects around if there's any possible model bias that one would actually witness, which means that today data scientists or the overall AI ecosystem is more intuitive, more aware to manage the biases. And I think it's also about not just the managing bias, but other regulatory regimes like GDPR in the Europe or data privacy by design are actually leading to killing the biases in ensuring there are less or no discrimination by the models. Few snippets. AI will definitely create millions of jobs. Then it will destroy. There's been a sentiment that will AI kill jobs. The fact is, no, it won't kill jobs. It's definitely going to create more jobs. Yes, what will change is the nature of jobs will change. The jobs will be repurposed. However, we would still need individuals to design, conceptualize, ideate. I was reading an interesting article which said AI is all about trying to understand. If you want a successful strategy around deploying AI, let's segregate the task between humans and machines. Let humans do what they're best at, and let machines do what they're best at. What humans are best at is creating data. Machines cannot create data. As human beings, each time we are typing a search on Google or keyword in Google, we are generating data. We are using our mobile phones to make a transaction. We are generating data. Computers are good at is analyzing and storing the data. As human beings, we cannot store gigs and gigs of data in our mind, but that's what is the capability of computers. So the best thing is let's try and segregate the roles and responsibilities of what humans are best at and what computers are best at, which actually brings to a point that AI will cause role changes, not necessarily job losses, that's for sure. And the future of AI, it's definitely here to stay. The Google CEO has already spoken about AI being more transformative to humanity than electricity. McKinsey reports the demand for data scientists will exceed supply by over 50% in 2022. PwC reports the global GDP could rise by 14% as a result of AI-enabled activities. which is equivalent to 15.7, close to $16 trillion. Look at that, the size of the market. The penetration of Amazon's Echoline, it currently owns 70% of the smart speaker market right now, and could add 10 billion to the company's top line by end of 2020. That's a big number. So that brings me to an end to my presentation. Will be happy to take any questions if there are any. Thank you. Okay. So I can see there's a question. What are your thoughts on the best skill set to focus on when upskilling the larger workforce on data and analytics without focusing on developing a data analyst or data scientist specifically? I would perhaps categorize this into two aspects. One is the technical, another is the non-technical side. From a technical side, I would say SQL and Python is a must that one should be we should be upskilling skilling our existing colleagues on. And the second is a non-technical. Logical reasoning is very important. If an individual gets stuck on a code, it is very easy to troubleshoot on Google. However, what Google will not answer is the logical reasoning, i.e. which table needs to be mapped with what data set. So it is important that we should actually inculcate a behavior which is all about people have a strong bend around logical reasoning. Okay, I've got another question from Jeff Ottino. If an organization has no formal analytical capability in place, how should they get started? Brilliant question. Perhaps there is similar to software as a service, platform as a service. Today, there is another regime which is AI as a service as well. And there are a number of vendors which currently offer AI as a service, which is more cloud-based. For a startup, it is, I would say it is rather easy for a startup to engage a third-party vendor, which is into AI as a service. Because let's accept the fact that if you were to set up an AI ecosystem within an organization, one, it could be slightly time consuming. Second, it's definitely cost intensive because you would need to actually set up the enterprise data warehouses. You would need to hire data scientists, which definitely comes at a slightly premium price in terms of salaries. And of course, then you would also need other tools as well. What's really useful is you hire and onboard an AI as a service provider, which comes with the complete package, much more cost efficient. Once you see there's a true merit in what you're deriving as a benefit from AI as a service provider, why not to set up an AI function internally? Okay. I've got another question from Urban Lim. It's inefficient to hire data scientists when they don't have access to data, can't get complete data sets. Absolutely, completely agree. And perhaps this is one of the challenges that is faced by majority of organizations. Access to incomplete data, access to poor quality data. And perhaps basis my conversation in the last 1 year with and leaders in analytics space, one of the challenges that they've said is data quality is one of the challenges, and a lot of transformation programs are actually being run to manage data quality. That brings me to an end of my session. Thank you so much for joining. If you have any questions, I'll be more than happy to connect.